Let's review the properties of kites and trapezoids. Here's a warm-up problem asking you to find the area of this trapezoid, and the formula is half of the height times the sum of the bases. So we'll take half of 4 times 7 plus 12, and half of 4 is 2. And 2 times 19 is 38 square units. Reviewing the terms pertaining to trapezoids, the bases are always the two sides which are parallel, and the legs are the non-parallel sides. There's a special trapezoid called an isosceles trapezoid where the legs are congruent. In this example, we're asked to find the length of that blue mid-segment EF. And we know that the mid-segment, the length of the mid-segment, is the average of the two base lengths. So if we want to find the length of EF, we'll take half of 25 feet plus 15 feet. That's half of 40 feet, and that's 20 feet. Okay, so here is a trapezoid. It looks like it's been rotated. The two bases are sides OP and MN, and we're asked to find the measures of the missing angles. We notice that this particular trapezoid is isosceles, therefore the base angles are congruent. So angle N also measures 107 degrees. And because the bases are parallel, we have the angles P and M are actually same side interior angles, and so they're supplementary. So the measure of angle P is 180 minus 107 degrees, that's 73 degrees. And the measure of angle O is also 73 degrees, again because this is an isosceles trapezoid and the base angles are congruent. The perimeter and area of this kite. Now this is a kite because it has two pairs of consecutive congruent sides. You'll notice side ZW and WX are congruent. Similarly, side ZY and YX are congruent. It's easier to find the area than it is the perimeter in this case. The area is very simply half of the product of the two diagonals. The two diagonals in this case are WY and ZX. So that's half of 12 times 10. And half of 12 is 6. And 6 times 10 is 60 square units for the area of this kite. Now the perimeter of the kite, you can use 2 times WX plus 2 times XY because those sides are congruent, the consecutive sides. But to find WX, you need Pythagorean theorem, and so it's the square root of 4 squared plus 5 squared, or the square root of 41. Okay, same thing for side XY. Pythagorean theorem says to find XY, we can do the square root of 25 plus 64, or the square root of 89. Now substituting those values back into the perimeter algorithm, we get the perimeter of this kite is 2 times root 41 plus 2 times root 89. That's the exact perimeter in units. So now let's have an application problem. Carpenters do use mid-segments of triangles and trapezoids. So here's a carpenter who's going to make a coffee table with a similar design as to the one shown. We learn that segment AB is the mid-segment of the trapezoid CMND. So that's the trapezoid that's on the top. And then CD is the mid-segment of the lower trapezoid. And we're asked to find the lengths of the segments MN and OP. So let's look at this top trapezoid. If AB is the mid-segment and AB is the average of the two bases, I can see AB is 1.5 feet greater than the smaller base, so MN would be 1.5 feet greater than the mid-segment. MN is 8 feet. Now let's look at this lower trapezoid, which is outlined in green. If CD is the mid-segment and CD is 1.5 feet less than base AB, then base OP is 1.5 feet less than the mid-segment. So OP is 3.5 feet. So there we've reviewed the properties for kites and trapezoids.